Are we ready to get started on the notes for today? No, I don't blame you. But we got to, because I want you to get started on the assignment. So again, I would like to invite you to move closer to the front so that you can see really good. If you still have your warm up because you have questions on it, then you can keep it. And after we're done with notes, if you want to come up, I will go over it with you. It's something that you have to know how to do, and you have to be able to do it kind of quick. It's fast factoring. It's the easy stuff. And so again, if you don't get it, then you need to keep your warm up and you need to come talk to me so that we can go over it together. For the stuff today, like I said, I guess before we get started, make sure you put your cell phones away. After one warning, you're going to have to go put it on the wall. Not worth it. I don't think you're going to need a calculator, but if at any time you feel like you need a calculator, you can go get one, but I'm not going to make you go switch your phone for a calculator. Reminder about the bathroom pass. I don't really mind if you need to use the bathroom, but make sure that you sign and put the time on the back wall. And I'd prefer that you didn't go during notes, but you've got to go, you got to go. So we are going to start polynomial long division. To do long division with polynomials, you have to first remember how to do long division with just numbers. Do you guys remember how to do long division? Like if I said we need to do 126 divided by 7. Maybe not. Like if it was like, are you smarter than a 5th grader and you had to go toe to toe with a 5th grader to do these, how are you going to do? No calculator. We're going to have to just figure it out. Do what? Possibly. Okay, so we're gonna remember how to do long division. So first thing we have to do is we have to set it up. So maybe this will be a little familiar. You set it up like this, and we put what you're dividing by in the front. Y'all remember this? Yeah, this is long division. Okay, so what do? To do this, we first look at, can 7 go into 1? No. Okay, so then we do, can 7 go into 12? Yes. How many times can 7 go into 12? 1 time. So you put the 1 over the 2. And then you do 1 times 7 and you put it down here. And then what do we do with the 12 and the 7? Subtract. That's important. So right now, the sign is, it's a positive 7, right? 1 times 7 is a positive number. We are changing the sign. We're making it negative. Okay. So we'll do 12 minus 7. What's 12 minus 7? 5. And then we will bring down the 6. And then it's how many times does 7 go into 56? 8 times. So you put the 8 at the top, and it's 8 times 7. What is 8 times 7? It is 56. And so again, we change the sign, we make it negative, and 56 minus 56 is 0. What does the 0 represent? Remainder. We're going to label this. So here are some more names. This is called the quotient. A quotient is simply the answer to a division problem. You've got, that number is called the dividend. Not dividend, dividend. And then the 7 is a divisor. So these are fancy math names, but if you look at the directions for for example number 2, underneath the big box in the middle of your paper, It says use long division to determine if the divisor is a factor of the polynomial. So you have to know what a divisor is. A divisor is just what you're dividing by. So those are all the names. When we write the result, what we just did, another way to write 126 divided by 7 is like that, right? Isn't that also 126 divided by 7? So just another way to write it. And our result was 18. The next part of the question says, is 7 a factor of 126? Why? You're right. Why? Sort of. Because it had a remainder of 0. So I think y'all were both saying the same thing. So is 7 a factor of 126? Yes. The answer, the reason why is because the remainder was equal to 0. All day, and this is for a couple of class periods in this unit, you need to know that whatever you're dividing by, it is a factor when the remainder is 0. Now, not every time does it have a remainder of 0. A lot of times it's not. That just means it's not a factor. So now, nod your head if, yeah, I guess I'm kind of remembering this stuff. It's been a long time since I did long division, but I probably could do the next one. So I'm going to do the next one up on the board. I want you guys to do it on your paper. If you get stuck, you can look up, but I'm going to be writing it on the board. So try the next one. It's a smaller number. You should get this. So we're going to set it up exactly the same. No, it's purely coincidence that they're both 18. Pure coincidence. Did y'all get the same thing? 18 with a remainder of 3. Okay, well, this one, when we write it, I think that way back when you learned how to do this, that's how you would write the answer, like maybe 18 and then R3, something like that. We will write it a little different. We're going to do big kid math. So the way that you write this, this is the same thing. You'll always write these as a fraction. 75 divided by 4. And what does it equal? It equals 18. And the remainder part is a little bit different how we write it. Lenina, why'd you give crazy eyes? Oh, the result? Oh, when you do the result, it's kind of like restating the problem. So 75 divided by 4 is equal to 18. And what's different is how we're actually writing the remainder part. So we're not going to do like remainder 3. We're not going to do R3. That's not how we will write it. The way that you write it, every single time, it will be a plus. So sometimes a remainder is negative. It doesn't matter. You start with a plus sign. The remainder is going to be always written as a fraction because what it's technically saying is like 4 didn't go in there. It went in there 18 and then a little bit more because there's 3 left over. So it's like how many parts of 4 still go in there. So what you say is whatever the remainder is. So if it's positive or negative, the negative sign is going to go on the top of your fraction. In this case, it's positive, so it doesn't matter. And then it's always going to be a fraction. And so when you look on this side and see whatever it was you were dividing by, it will always match over here. It will always be the same. So you write the remainder as a fraction, and it's a fraction over whatever it was you were dividing. Michaela, do you have a question about the division? The 8? Okay, so we first do how many times does 4 go into 75? 1 time, so you put the 1. 1 times 4 is 4, and then you have to change the sign. 7 minus 4 is 3, right? Okay, and then 4 can't go into 3, so you got to bring down the next number. You bring down 35. So 4 goes into 35. Well, 4 goes into 35 8 times because 8 times 4 is 32. Does that make sense? Okay. So let me ask you this. Is 4 a factor of 75? Why? Because the remainder is not 0. So that's how you can say it. No. Why? Because the remainder is not 0. Okay, so far, are we good? We kind of remember how to do long division. Factor theorem. Well, we just talked about something being a factor. So it says when a polynomial, so just some polynomial, if it's divided by a factor, then the remainder is always equal to what? 0. Okay, for something to be a factor, the remainder needs to equal 0. That's when you have a factor. It is a factor when the remainder is equal to 0. That's all that means. When something goes in there evenly, you're a factor. And it sounds crazy and intimidating because it's a factor theorem, but that's all that it means. Okay, let's do division with polynomials. This seems scary, right? Well, we can do this. So what we're going to do is we will set it up the same way, but here's something that's extremely important. You always have to check for missing terms. Missing terms means that if you're looking at something, so this first polynomial, when you look at the x terms, see how it's x to the 3rd power, and then it goes to the 2nd, and then it goes to the 1st, and then there's something with no x. So it goes 3, 2, 1, and then none for the exponents, right? So we aren't missing anything. It has to go like that in descending order, and you have to have the biggest one written first. There are no missing terms there. Like that's good. 3, 2, 1, and then none. For this one, I have 2 and then a none. So I'm missing x to the 1st power, right? If you're missing it, it's because there are none of them. So when we write this problem, you have to make sure that you include plus 0x. It's a placeholder. If you're missing a term, you have to add it in. While we're at it, let's go ahead and look at B. B goes from 3 to 1. So I'm missing the squared term. So right there, I need to add plus 0x squared. And I'm also missing a constant term. So I'm also missing plus, a constant is like just, you can write plus 0 at the end. So you have to have placeholders for everything or it's not going to. And here is a hint. There's always something on a quiz that has a missing place. So please always check for that. For the first one, we're going to set it up like we did that long division problem at the top. So I'm going to have thing I'm dividing by. And when I do this, and on your paper, what we're going to do is leave ourselves a little bit of work room right over here to work. So don't line it up as far as you can this way. We're going to kind of shift over just a little bit before we start writing. And some of you, maybe you write really big. If you need to do it on notebook, if you need to do your problems on notebook paper, that's fine. So we will have x squared plus 0x plus 1, and it's going to divide into, make sure you leave yourself room at the top. These problems set up exactly the same. So I mentioned side work. If you watch like math videos on your own, or if you have help or a tutor or something and they're looking at your work, they may be like, what is this stuff that you're doing off to the side? This is extra work that we're doing, but I promise in all the years I've taught, because you also teach this in pre-cal, that the students that do this extra step get better answers. So please do this extra step with me. Off to the side, what I'm going to do is I'm going to keep rewriting this right here. I'm going to keep rewriting that piece. So I'm going to off to the side write x squared plus 0x plus 1. This is kind of like my side work. To figure out, because like up here, it's like, oh, okay, how many times is 7 going to 12? Well, how many times does that go into that? I have no idea, right? Like, where do you even start? What you do every single time is you're only looking at the very first term. And what you're looking at is this x squared piece. And so it's what times x squared would give me the very first term, 4x cubed. Well, let's just look at the number parts first. This is a 1. How do you make it a 4? What do you have to multiply by? 4. So we're going to put a 4 out there. And then for the x parts, I have 2, but we need it to be a 3. So what do we have to multiply by? How many x's are we missing? Just 1. So you multiply by x to the first power. So if we multiplied that by 4x, and I'm going to distribute this in, 4x times x squared would give me 4x cubed. 4 times 0 is 0. X times x is x squared. And plus 4x. So off to the side, all I did was distribute in whatever it is that I need to multiply by. So this is why we had to refresh our exponent skills. Do you guys agree with what I get when I distribute that in? Okay. So now we have 2 things that we're going to take and we're going to go put back in our problem. So we have that right there and it's on top. We have this right here and it's on bottom. So we have 2 things. We have something on the top and we have something on the bottom. That's where we're going to go put them. So that part, I'm going to go take and I'm going to put it on the top. So that's what goes up here. And I line it up with whatever the x value is. So like this is to the first power, so it goes over the x to the first power. So I put 4x over here. I have this stuff which came out on bottom. That stuff is going to line up underneath. It's going to go here on the bottom. So I'm going to go line it up. So remember, you can only add and subtract like terms. So that's why you have to have like place value. They all have to line up. Back here, we had to change the sign every single time. You still, when you're doing long division, have to change the sign, but it's a little different here because it's every single term. So this is another step that not all teachers do. So if they're looking at your paper wondering what you're doing, it's just my craziness. So as I change the signs, I'm going to circle them. Why? Because it lets me know that I just changed them. Sometimes somebody walks in the door, somebody asks you a question, you go to the bathroom in the middle of a problem, whatever the case may be, you don't remember if you changed the sign or not. If you circle them, then you know you changed them. Every time that first term will disappear. So I have 4, I take 4 away, I have none. That's our goal every time. So then down the other columns, however many you have, you just evaluate. So I have -7, I'm subtracting 0, so I still have -7x squared. Did y'all get the same thing? Okay, now all I'm going to do is bring down the next term. Every time you'll bring down the next term. And you keep doing this process until you cannot multiply by something to give you the next term. So here, I can ask myself, can I multiply x squared by something to get -7x squared? Yes, I sure can. So off to the side, I'm going to do it again. And what do you have to multiply x squared by to get -7x squared? -7. I put plus -7. When I go to rewrite that, I'm not going to leave it like that. Another reason that we do this is because most teachers teach it where you have to do this all in your head. I am not good at doing math in my head. I have to write things down. I just cannot. Another thing, a reason why we do this is because as we find the things down here, a lot of times what happens is that we forget to write the stuff up here. And then if you're trying to work backwards and figure out what it was, and then you already changed the signs of things, then it can be confusing. So if you write this stuff down, it's really easy to go back and fill out the top, because the answers are always what's in front of the parentheses. So again, I have two things. I have this stuff on top, so that's going to go up at the top. And then I have the stuff on the bottom, and I'm going to go line it up. Before I go to combine this, I have to change the sign, and I'm going to circle it every time I change it. Especially when you have something that has a negative and a positive, if you don't circle it, then how do you know which one to use? Like here, if you just put a negative out in front, how do you know if you're using the negative or the positive? So now we're going to go and add each one of these columns. The first one will always dissolve. You'll always end up with 0. Did y'all get the same thing? All right, so now I look, okay, is there something I can multiply x squared by to give me just x? No, if I multiply by 0, I would get 0. So here's the thing, you can't multiply x squared by something to give you a lesser value. So whenever you get to a point where this exponent is bigger than this one, you stop. So what? This is the remainder. So as soon as you get to a point like this, didn't we fill up all of our place values? Like there's no more places. So you're done. This is your remainder. So let me ask you, is x squared plus 1 a factor? No. Why? Remainder is not 0. So that's how you answer that. No, the remainder is not 0. To write our result, and you have to write kind of tiny, we're going to set it up the same way. I'm going to write the first thing divided by the second thing. And you don't have to put, no, it's not squared, it's cubed. You don't have to put missing placeholders when you write your answer. Like you only have to do it when you're actually multiplying. So I set it up the same. I divided this, and my answer was 4x minus 7, and I had a remainder. So I have to do plus whatever my remainder is. So in this case, it's negative 15x plus 12 divided by this. It's the same looking fraction. So every time you're going to do plus whatever your remainder is. So that has a minus 15, you put it up at the top. And the fractions will have the same denominator. Polynomial long division. Okay, let's do one more and then you'll be able to get started on your assignment. So first thing we have to do is get the problem set up. So we're going to set it up same way. If at this point you realize I can't fit it all in there, we'll just grab a sheet of paper and you can do it on a sheet of paper. So I'm going to set up the problem. So off to the side, we're going to jot down our side work. And every time it's going to be x plus 3. So what times x could give you x to the third power? X squared. So we'll distribute that in. Did y'all get the same thing? All right, so I've got a part on the top and a part on the bottom. I'm going to go put those into my problem. So the x squared needs to be over the x squared column. And it's a 1x squared. You can put the 1 if you want to. You don't have to. And then underneath, I'll put the rest. Before I can combine this, I have to make sure that I change all the signs. The first term will always equal 0. And then I just have 0 minus 3. So minus 3 x squared. So I will bring down the next term. And then I will do my side work. What do you have to multiply x by to get negative 3x squared? Negative 3x. So I have two parts to my side work. I'm going to put the top on the top, the bottom on the bottom. Before I can combine these, I have to make sure I change the signs. A lot of people want to stop there and they're like, oh, I can already see that it's going to be 0, whatever, I'm stopping. No, do not stop. You have to show me that the remainder is 0. At this point, I get 0, and can I multiply x by anything other than 0? No, like the only way to make that turn into 0 is plus 0. And so here, I could add plus 0, but I don't have to. So my result, I'm going to practice writing my answer. I want you to practice writing your answer. For this one, I don't have to write a remainder because there isn't one. Is x plus 3 a factor? Yes. Why? Yes, because the remainder is equal to 0. So that is all we are learning today, because these problems kind of take a little bit of time. I wanted to make sure that we finished and you had enough time to start these problems